Good morning to all. Today I'm going to continue the discussion on the Newton ring. In the previous lecture, I have detailed about the formation of the Newton ring in case of reflected and transmitted, where we have established the expression for the diameter of bright and dark ring in both cases. And precisely we obtained a dependence of the diameter on the order of the fringes, that is Newton ring. More precisely, in this lecture, I'm going to detail the two application of the Newton ring. Whereas the Newton ring experimental setup has many more application than these two. But these two are more important. First, that is the finding the wavelength of light, and second is determining the refractive index of the liquid material. So let us start. As you know, the diameter is depending upon the number of fringes or order of fringes. So first we try to compute the wavelength of the monochromatic light source, and then in this lecture we discuss the refractive index of the liquid introduced in place of the air. So in this first, that is determination of the wavelength of monochromatic light, we know that the diameter is directly proportional to the order of fringe and the wavelength and the radius of curvature. For determine the wavelength of monochromatic light, we firstly measure the diameter of the nth dark ring. In case of the reflected light, so we have the dn square is equal to 4n lambda r, where the diameter of the nth ring is computed through the microscope, and the capital R is also computed through the many devices, such as the spirometer is used for the calculating R, or the focal length formalism can be used to calculate the capital R. Now, after knowing the value of the dn and capital R, then we calculate the value of n plus pth ring's diameter in the same way as calculated the diameter of the nth ring, where p is your known. So from the reference point, we move the p ring, which is fixed value ring, let's say 10, 8, 12, 18, anything that is integer. So we have the dn plus p whole square is equal to 4n plus p lambda r, where r is not going to change, so that's why it is fixed value. After knowing the value of the dn plus p and dn, with the help of equation 1a and 1b, we try to calculate the difference between the. So dn plus p whole square minus dn square must be equal to the 4n plus p lambda r and minus 4n lambda r, which results the 4 lambda p capital R. And now calculating the lambda, so dn plus p whole square minus dn square divided by 4 capital RP, where dn plus p and dn are computed through the, sorry, this is visible to you. Once again, you see the difference between the equation 1b and 1a. It will give you the 4 lambda rp, and where the lambda is computed, because dn plus p is known and dn is known, computed through the microscope, and capital R is computed through spirometer. So p is a known value. We are able to compute the value of the light source wavelength. So it is a very important application. For any monochromatic source, you are able to calculate the wavelength of the light. Now, how do we measure the refractive index of the any liquid? So the determination of the refractive index of the any liquid, we firstly observe the wavelength of the light with a Newton ring assembly having the air wedge shaped thin film. So the lambda air is equal to, as in a previous case, dn plus p square minus dn square divided by 4p capital R. The value of diameter of the n plus pth ring is measured through traveling microscope, and the diameter of the nth ring is also measured through microscope. Capital R is measured by spirometer, and p is known. In that way, the wavelength of that source is measured. Secondly, we will repeat this experiment from the same set of the n and n plus p fringes. Only the difference is there. We introduce the liquid in place of the air. So you can see how do we perform this experiment. We observe the wavelength of the light with the Newton ring assembly having the liquid in place of the air. So we have a air wedge shaped thin film, and in that way, after introducing the liquid in place of air, the diameter of the fringes is decreased for the same value of n plus p and n. So the value of the dn plus p dash and dn dash are being measured through the microscope, and then we have the value of the lambda dash due to the liquid. Having lambda dash is equal to dn plus p dash square minus dn dash square divided by 4p capital R. Remember, the value of p are always be same in both experiments. So we also know a relation between the refractive index and the wavelength, which is, of course, the refractive index is given as lambda air divided by lambda dash. By substituting the value of lambda air and lambda dash from the equation 2a and 2b, we would have a relation such as dn plus p whole square minus dn square. This is measured in the air, and the difference between the same n plus pth ring squares of the same rings, that is liquid. So we have a relation for the refractive index. So equation 1 and 2 are very important equation for computing the wavelength and the refractive index. Whereas these relations are very important to compute the values of the wavelength and the refractive index. So please always have these equation in your mind, and which are very important to solving the numerical problem also. Thank you all, and I advise to all of you, please go through the some standard book. Thank you once again.